Hi, Slew members, and welcome to the latest Clubhouse clip. It's so fun to be back with you guys in the Clubhouse. I appreciate you guys lasting through this dry spell where the Canary Islands, there were some dust storms going on, there was some weather going on, and you can see there's still some weather going on by the clouds here in the live all sky view, but that, frankly, is not going to stop us here tonight. We are going to get through it, and we actually have some great live views of some very, very cool galaxies coming up. They are some of our galactic neighbors in the sky that are both very unique, but in very uniquely similar ways. We're going to talk about how they've been evolving through the course of the universe's history and have a really great way of showing it to us and through our telescopes. So thank you for coming along for the ride. This is our giant galaxy night. And I'm going to be accompanied tonight by Bob Berman, who has really so much knowledge in particular about these two galaxies, and so it's really going to be great to get into them with him here as well. So thank you, Bob, for coming with me here tonight to wander about the universe.
Are you kidding, Eric? This is so exciting. These are two of my favorite galaxies, and we're going to look at them close up and long exposures of them. And whoa, I can't wait to begin. This is great.
Really, yeah, it's exciting. Looking at this all sky view just gets me, all excited for what's to come. And I mean, really, what's the point in drawing it out any longer? We do have a view of our first galaxy coming up here. I believe it's M51, which is, bam, right there. This is our galaxy number 1, and we're going to see it in the next few minutes just flush into color. And this is a live view here, and it's being processed live in front of our very eyes. This is Slew, and we're going to talk about the mysteries and the discoveries of this object as it's coming into view. But yeah, isn't this a great galaxy to start with?
Oh, yes, it is. This is M82, discovered
Oh, M82. Oh, right, M82.
way back, yeah, in the final years of the 18th century. And what to make of this? I mean, you can see that. Is this some kind of odd elliptical galaxy? Is it an irregular galaxy? As time went on, we could see that there's material coming from the center, and wait till the color image comes through. And then it was called an exploding galaxy because it looks like someone set off dynamite in the middle of it, except not a single supernova has ever been seen. And then when we were able to start measuring things well enough, we saw that it was only 12 light years away. That's darn close, one of the closest galaxies to us. And it's a member of a pair. They're only separated by about the width of the Milky Way. Imagine one Milky Way width separates a kind of normal spiral galaxy M81 from this. This one's only about a third the size of our Milky Way, but something is happening to it. And it turns out that its companion galaxy has been stirring it up. They're in a state of near collision, they're going around each other. And this one is tidally stressed to produce bursts of activity. And should I keep going or give you a moment to say anything? I mean, I could just keep going about this because it's so exciting.
Well, I just have, I mean, so many questions to ask about it. That's amazing. Like, for us to be able to understand that these galaxies are interacting, like, how do we learn about that? How do we figure that out? Like, what are the signs that tell us that?
Right. Well, in this case, the sign is right there in front of us that something weird is happening, and weird stuff doesn't happen without a reason. Things really changed in 1953 when we got our first radio telescope images of it, and it became obvious that it was the brightest in radio wavelengths in that entire region of the sky in the Big Dipper. And so its name changed again. Instead of a irregular galaxy or an elliptical galaxy or an exploding galaxy, we started calling it Ursa Major A, the loudest source in radio wavelengths. And then when we launched a X-ray telescope for the first time in the 1990s, we found that it's an intense X-ray source, except the X-rays are not coming from the exact center the way you'd expect in most galaxies that have a supermassive black hole. They're 600 light years from the center. It's off center. And turns out it's the first ever intermediate mass black hole. Not an ordinary star sized black hole like Cygnus X1, not a supermassive core black hole like the one we see sitting heavily in M87. Now, this is a strange one
Oh,
that's off center.
and look
And
at
look at
this.
this.
This is it flushing into color right now. That's
This is
just
so great.
gorgeous.
And that still wasn't the end of the story. Then came infrared measurements. And when we could take infrared, that's essentially heat. You know what we saw here? Uh, the brightest galaxy in the universe in infrared light. Now, there's 200 billion galaxies in the visible universe. And this one gives off more infrared than any other. And there's only a handful that give off more infrared than its brightness would suggest. I mean, this is plenty bright. It's got far more, 5 times the surface brightness of our own Milky Way galaxy. So it just shows lots of stars are bursting into existence here. And it turns out there's 10 times more starburst here in M82 than in our own Milky Way. So now we have a new name for it. Now we call it a starburst galaxy. And I think that's the name that's going to stick because it's not exploding really. What's happening is that new stars are being created at this crazy, frenetic pace. And in doing so, we're getting an excess in all parts of the spectrum in the visible, in the infrared, in the X ray, in the radio uh, part. And in some of these, it's downright intensely riotous in the radio wavelengths, in the infrared. In other words, there's more heat coming from this than any other perceivable galaxy in the entire universe. So it's a very, very special event. The very nearest galactic collision to us, only 12 million light years away. You know, considering that we could see galaxies billions of light years away, and sometimes do. Our slew members sometimes choose very distant galaxies. They don't look like much because they're so tiny that they look like little smudges at that distance. But this is the closest.
And it serves as really a great analog for what's about to happen to us. I say what's about to, but maybe in terms of the universe, we have a collision to look forward to with Andromeda. The galaxy is coming to the Milky Way for a visit, for a very long-term visit, and we're going to experience some things. And I mean, would we expect things like bursts of star formation to happen to us once a collision comes our way?
Absolutely. Just as we're seeing crazy star birth there, as Andromeda comes closer and closer to us, it may only be 4 billion years before we merge into a single galaxy. And as
Okay.
that
So in our
happens,
lifetimes, like we can make it, can't we? I
I mean, right now, picture it as two footballs um, us and Andromeda separated by about the length of a large living room, maybe 25, 26 feet, coming closer together by about one football length every 100,000 years. And then you have the sense of how we and Andromeda are merging with each other. The distance decreases by 70 miles per second, but that's what it amounts to in terms of the two bodies coming together. And that's what's happening with M82 and M81, two galaxies in Ursa Major. It's a very lonely, empty part of the universe. And the Hubble deep field image that was taken, if I remember right, it was 1995, and they tried to find a spot that was didn't have a lot of gas and dust, and that was a clear window to the rest of the universe. And the Hubble astronomer who started this chose this spot right next to this galaxy for a 100-hour exposure. It was unheard of to spend that much Hubble time staring at one spot in the universe. But by gathering light, they got all the way down to 30th magnitude and could see objects at the edge of the visible universe. And to give you an idea of how faint that is, 30th magnitude is the same brightness as the glow of a cigarette on the moon, as seen from Earth with the naked eye. Glow of a cigarette. Of course, nobody. It's really a no smoking zone. They don't allow smoking there. But that's how dim that would be. And we use this spot right next to this Galaxy M82 to take that picture. Hey, look at this as more detail comes in. You see that material near the center? It turned out with infrared photography that this has spiral arms that could be seen in infrared. So it turns out it really is a spiral galaxy after all. And speaking of spiral galaxies,
Yeah, that's a good
whoa,
example. Our
whoa,
wonderful
whoa,
whirlpool
we're
galaxy.
going to M51 now, and this is, if you can possibly top M82, M51 does this. Now, here, quick history of M51. Discovered by Charles Messier in 1773, and it was just kind of a blurry thing. And it took a full lifetime before telescopes got good enough to see it as a spiral. Lord Rosse did that in 1845, recognized its spiralness, but it wasn't thought to be a galaxy. It was thought to be maybe a solar system. Like the center would become a sun, and those spirals would become planets going around it. And he found 14 of those. So for decades, there were 14 spiral nebulae known. And they were thought to just be in our own Milky Way galaxy. It took until Edwin Hubble showed us that these things are actually separate island universes, as they were called then, island universes, to know its true distance. Which, by the way, what the heck is its true distance? You'll see figures of 20 million light years, 37 million light years. Oddly enough, this very famous whirlpool galaxy, we're still not sure of its distance. And so the distance estimates are still discordant. In any case, it's about half the size and mass of our own Milky Way, but enough beating around the bush. What's special about it is that it too is a colliding galaxy. We just looked at one colliding galaxy, and you can see that there's two galaxies in a state of collision. The one above it is the small galaxy NGC 5195, and material is stretched between them like pizza cheese being pulled from the main galaxy to the other. In truth, that smaller galaxy passed right through the larger one about 500 million years ago, before there were even dinosaurs, then passed through it the other way about 100 million years ago. So that little galaxy at the top is like a spider, like a fly trapped in a spider web. It's gravitationally bound. It can't escape. It's going to be pulled in. It's going to merge with the larger galaxy. It's now orbiting around it tighter and tighter and closer and closer. It's losing its integrity. Um, but there's something else strange around it. Remember what you and I talked about before the show began? That surrounding that topmost galaxy, NGC 5195, it looks to be like a coil in a bed spring or a spiral or a bit of DNA. You see that strange coiled spiral structure that seems to surround that top galaxy?
Right above there. I'm looking at it. It's a little bit of a Rorschach test.
Yes, but you can see enough of it, especially as our SLU telescope brings the image into greater and greater clarity. You can see on the left side that it's not just an up and down gas cloud, it's circular, it's a spiral, it's a coil, like a bed spring. And I've not seen that in any other galaxy in the whole universe. I've not read any analysis of this. We've just asked one of our SLU partners, Matt Francis, to take a long exposure image through his telescope, and we'll share it with you when we get the results of that. But it's a very strange object. So here again, we're looking at colliding galaxies. And remember a moment ago when we looked at M82 and said that that had an infrared excess, in fact, more infrared, more heat coming from it than any other galaxy. Well, there's just a few other galaxies in the universe that have an infrared excess. In other words, more infrared relative to the visible light. One of them is Centaurus A, which we see from the southern hemisphere. But the other is this one, that topmost galaxy, NGC 5195. It's giving off far more heat than it ought to compared to its light. And so, once again, the explanation is the same as in the other case, that star burst activity is occurring. It's being incited to gas clouds roiling and moving and collapsing to form new baby stars by the presence of that galaxy behind it. Actually, the other galaxy is actually in front of it, close to it, capturing it, and this is producing intense starbursts. And actually, both galaxies. I think Eric, you mentioned before that in the main galaxy for another 100 million years, there should be excess starbirth also.
It's just stealing up all the gas and dust in the galaxy way, way before its time if it wasn't going to be merging like this. And so it, it's amazing to think about because it's on such a large, long scale. You were talking about how these galaxies crisscrossed each other before even the dinosaurs were around for us. But these galaxies are evolving on these really long scales, which can be made considerably shorter by this merging. And so it's oh, and here it is coming into full beautiful color.
My
And you
goodness,
can
is
see
this
significantly just
beautiful
the
or is this
dust lanes.
beautiful? My goodness. You know, and when we talk about the expanding universe, the galaxies we saw earlier are really part of our local group, or at least on the fringes of it. So they're not showing much expansion at all. But this galaxy pair is racing away from us at 350 miles per second. So as you and I converse and talk about it, Eric, every second it's 350 miles farther away. So it is participating in the expansion of the universe while that topmost galaxy continues to orbit around the bottommost one. And is this a thing of beauty? And it's natural color too. We're seeing the true colors here.
And so this is really slew members. This is a miss it if you blink moment. If you happen to blink for hundreds of millions of years, but it's very very much going to be just for a certain amount of time that we'll be able to see this beauty. And I'm just loving how you can see trails heading off the galaxy. Like right here is one in particular that's just you can see sort of this dynamic process that these galaxies aren't in the standard spiral shape you would recognize it in. There's been disruption here that has been caused by the chaos of this merging.
That's right. And of course, the main bit of disruption is that long thing like stretched out taffy being pulled from the main galaxy, the Whirlpool galaxy, to that companion. And that's right, that long string. And this is true color. You know, very often we get astrophotographers who like to crank up the blues in this galaxy. That is, the hot stars are glowing blue, the pinks are uh, glowing hydrogen gas regions that are giving off what's really the universe's favorite color at 65, 63 angstroms in the red. And we're seeing it all in the actual colors. You know, we could of course fake it and crank it up and make it artificially bluer, but this is how it really looks in real life. I'm still now looking at that topmost galaxy and how it's sitting in this very odd formation of what appears to be nebulosity. So there is strange violence going on here in the whirlpool. It sits in the constellation of Canis Venatici, the hunting dogs, just off the handle of the Big Dipper. And so you'd think that's an odd place for a galaxy, but it's really a member of the Virgo cluster of galaxies. And if you think of where, if you know the night sky a little bit and know the constellations, Virgo is out as the Big Dipper is out. So they're not terribly far away. So this is really a member of the Virgo cluster, the nearest super collection of galaxies, about 5,000 galaxies that we ourselves are just sitting on the fringes of.
It's there is so much to see, and I mean, I thought it was a great point you brought up a little earlier that we look at these amazing galaxies that are in just this full view color and are absolutely gorgeous nearby us, but we also look further and deeper out into the night sky. There's just a lot of things to look at. And I also wanted to mention in particular that we've gotten a little bit more into planets recently. There's going to be a lot of planet stuff at SLU that's going to be coming up. We're going to be having actually Friday night. Saturn is going to be at opposition. It's going to be closest to us at Earth that it's going to be this year, and so that's going to be a lot of fun. We're going to have a show on that Friday night, and then the night after that, we're going to be looking at Neptune as it comes back into view in the morning of the Canary Islands. And so there's lots and lots of planet stuff, but not just for our live shows, but for our SLU members as well. Like I just sort of wanted to venture a little bit into the clubhouse and see sort of what we could find here. Like for example, what's your favorite planet, Bob, or either your most hated planet or your favorite planet, whichever. In the
Well,
solar.
Saturn, just
All
because
right.
it's so darn beautiful. You know, it doesn't show the detail Jupiter does, but it's so beautiful, as everybody will see when they join us on Friday night.
So yeah, I'm looking here. I just searched Saturn in the search box in the clubhouse, and look, there's all this stuff. There's a Saturn watch group that's popped up. Somebody asking for a little bit of help in imaging Saturn, and then people will be coming over to help. Looking at Saturn from Chile. Just talking about Saturn. So if you're passionate about a particular planet in the night sky, just search for it, and you will find something for yourself. And if you can't find that particular niche on that particular planet that you're looking for, hey, you can create it here. That's also something that you can do. So there's a lot of fun to be had, and of course, we're going to be going through the planets with our live shows because there's a lot of particularly interesting things happening with those outer planets this week, and so that's going to be a ton of fun. So we've been moving, from far outward, deep sky objects to getting a little closer into home. But at the same time, as we've been talking about these galaxies, they act as examples of what we may experience in the future in the Milky Way, and give us examples of how galaxies form and evolve, and which is so important to understanding ourselves. So it's a great path to travel along. And as we're sort of closing here on this show, I was wondering, Bob, do you have any sort of last thoughts about these really fantastic galaxies that we were able to explore tonight?
Oh, they were just so beautiful. Whether you see it for the first time or the thousandth time, uh, do these galaxies lose their beauty and their fascination? No, no, they really don't. And Saturn coming up on Friday. I hope everybody tunes into SLU then, because the rings are going to be better presented and the planet's going to be larger and with the rings better shown than in the last dozen years. So that's saying a lot. I mean, that's Saturn's gorgeous at its worst, but and this is the season because you come back in the fall and there's not going to be any planets. Venus is going to be gone. Really, it'll be in the morning sky, and Jupiter will be returning, but not until the wee hours of the morning. And Saturn will be gone. So this is the time. Just like our lives go with flows, and Earth has its own ebb and flows of the seasons. The universe has its own flow, and the flow right now is for great planets.
Absolutely. And yeah, just bringing up here, this is Saturn through the years, different imagery that's coming through our planet.
Sideways, and there's the rings opening up now, and now they're opening up further. And by opening up, look how you can see the rings almost touching the edges of the limb of the planet. And then now finally look at this. And now we're looking at the current Saturn, where the rings are just as good as they can get, where you can see all the rings one after another and that dark gap between them. Gorgeous in true color.
Absolutely. So we take part in observing the evolution over here at SLU, whether it be of galaxies on their scale or Saturn on its scale. And so yeah, I'm so glad you've taking the time to come and enjoy and watch the universe with us. And thank you again so much, Bob, for joining me here. This is a great night, and we're gonna have a lot more nights planned just like this. So stick around in the clubhouse, and we will be back before you know it. But thank you again, and this has been Eric and Bob
My
for Slew.
my pleasure. Thank you.
Live views of some very, very cool galaxies coming up. They are some of our galactic neighbors in the sky that are both very unique, but in very uniquely similar ways. We're going to talk about how they've been evolving through the course of the universe's history and have a really great way of showing it to us and through our telescopes. So, thank you for coming along for the ride. This is our giant galaxy night, and I'm going to be accompanied tonight by Bob Berman, who has really so much knowledge in particular about these two galaxies, and so it's really going to be great to get into them with him here as well. So thank you, Bob, for coming with me here tonight to wander about the universe.
Are you kidding, Eric? This is so exciting. These are two of my favorite galaxies, and we're going to look at them close up and long exposures of them. And
Hi, Slew members, and welcome to the latest Clubhouse clip. It's so fun to be back with you guys in the Clubhouse. I appreciate you guys lasting through this dry spell where the Canary Islands, there were some dust storms going on, there was some weather going on, and you can see there's still some weather going on by the clouds here in the live all sky view, but that, frankly, is not going to stop us here tonight. We are going to get through it, and we actually have some great
whoa, you know, I can't wait to begin. This is great.
really, yeah, it's really it's exciting. Looking at this all sky view just gets me, all excited for what's to come. And I mean, really, what's the point in drawing it out any longer? We do have a view of our first galaxy coming up here. I believe it's M51, which is bam, right there. This is our galaxy number one, and we're gonna see it in the next few minutes. Just flush into color, and this is a live view here, and it's being processed live in front of our very eyes. This is Slew, and we're gonna talk about the mysteries and the discoveries of this object as it's coming into view. But yeah, isn't this a great galaxy to start with?
Yes, it is. This is a M82 discovered
Oh, M82. Oh, right,
way
M82.
back, yeah, in the final years of the 18th century, and